Fifth chapter, sequence and series. So it is basically a continuation of IGCSE, and we'll be studying mostly AP and GP, where AP is arithmetic progression and GP is geometric progression. So just for the prior knowledge, write down the next terms of each sequence. So we see that 2, 7, 12, 17. There is a difference of 5. So we are adding plus 5 to write the next three terms. We'll just keep on adding 5, and 17 plus 5 is 22, plus another 5 is 27, plus another 5 is 32. So basic knowledge, and use the given answers to three significant figures. So 2 raised to power x is equals to 50. You can solve that by logarithms. X is equals to log of 50 to base 2, and so on. So first arithmetic sequence, which is having common difference represented by d. It could be a positive or negative number, depends if the sequence is increasing. For example, 5, 7, 9, 11, the sequence is increasing and the difference is 2. So common difference in this case is plus 2. And then the second one, 12.5, 10, 7.5, it is decreasing and there is a constant decrease of minus 2.5 in every successive term. We have the general formula. Sometimes it is written as un, sometimes it is written as tn, known as term number is a plus n minus 1 times d, where a is the first term and d is the common difference. If we just work out for this formula, which is 5, 7, 9 and 11, so the general formula would be a plus n minus 1 times d, where a is the first term, which is 5, n minus 1, d is the common difference, that is 2. Keep on simplifying, 5 plus 2n minus 2, 5 minus 2 is 3, so that is 3 plus 2n. Now what is this used for? If I just check rather we got it correct or not, so if I try the third term, so that is 3 plus 2 into 3, 3 plus 6 gives me 9. So I can now directly find whatever term I wish to. For example, 3 plus 2n, and if someone asks me what would be the 17th term, so I'll do 3 plus 2 into 17, that is 34 and 37. So I don't have to write all the terms. I can directly get that the 17th term is 37. These are basic examples. Let's go to the exercise directly. Have you done it before, or is this your first time? Okay. So for each sequence, write down the first 4 terms of the sequence. We have the formula, and write down a and d. We'll come to that. So first 4 terms, I am just substituting 1 in place of n, and I get 5, 1 times 5 plus 2 is 7. Then 5 into 2 plus 2, that is 12. 5 into 3 plus 2, 17. 5 into 4 plus 2 is 22. So first 4 terms done. Now it says write down a and d. A is basically the first term, so a is equals to 7, and d is the common difference. We can see these are increasing by 5. Let's try this d part. When we plug in 1 minus 10, we get minus 9. 2 minus 10, we get minus 8. 3 minus 10 is minus 7. 4 minus 10 is minus 6. So the first term in this case is minus 9, and the common difference is minus 1. It keeps on decreasing. So normally common difference is whatever is in the second place minus whatever is before that. So we may select any of the 2 terms. For example, you select these 2. So the later term minus the previous term gives you the difference. So in this case, minus 6 minus minus 7 would give you the difference. So that was plus 1. Minus 6 plus 7 is plus 1. Question number 2. Find the nth term. In question 1, formula was already there. Now this question requires us to find the formula and the 10th term in the sequence of arithmetic progression. So when I look at this is 5, 7, 9, 11. So first term plus n minus 1 into d, difference, I can see the difference is 2. I am using this formula a plus n minus 1 into d for each of these. So a is the first term, d is the common difference. So 5 plus 2n minus 2, 5 minus 2 is 3, 3 plus 2n. Now I have the formula for this sequence. And what is the 10th term? That is 3 plus 2 into 10. 3 plus 20 is equals to 23. Let's try for this. So first term is 5 n minus 1 and the common difference 5 and 8, the difference is 3. Now we simplify 5 plus 3n minus 3, 5 minus 3 is 2 plus 3n. So I have the formula and the 10th term for this would be 2 plus 3 into 10. 2 plus 30 is 32. Question number 3. Calculate the number of terms in each of the following arithmetic sequences. Now the first term is given, the last term is given. So we have to find the number of terms. First I'll go through to find the formula. Okay, let's say the question is 3, 7, 11 and then the terms are missing 83 and 87. So we have to find how many terms are there. General formula is a plus n minus 1 times d. I'm looking at the first 3. So this is the first term plus n minus 1 and the common difference is 7 minus 3, that is 4. Simplifying 3 plus 4n minus 4. So 3 minus 4 plus 4n is 4n minus 1. Now this is the term number. Now I'm looking at the last digit, last number, that is 87. So if I just put 87 right there and see what n comes out to be. So 87 plus 1 is equals to 4n. 88 is equals to 4n and 88 divided by 4 is n and n comes out to be 22. So there are 22 terms in this given sequence where this is the first term, this is second term, this is third term and this is 22nd term. Any confusion? Question number 4 says the first term of an arithmetic sequence is 14. Question number 4, a is equals to 14. The fourth term is 32. So I'm writing term 4 is equal to 32. Find the common difference. So I have a equals to 14. Fourth term is given and I have to find the common difference. So when we look at our formula, that is a plus n minus 1 into d. Now I have few values. Fourth term is 32. So what if I use 4 here? I know the value of a already, that is 14. N is 4 minus 1. Common difference is unknown. And we know term 4 is 32. So 32 is equals to 14 plus 3d. 32 minus 14 is equals to 3d. 32 minus 14 is 18. 18 by 3 is equals to d and difference is equals to 6. Question 5 says a sequence is generated by the formula, and let's copy that. The sequence is generated by the formula and the formula is given un is equals to pn plus q, where p and q are constants to be found. Given that u6 is equals to 9, u6 is equals to 9, one information. u9 is equals to 11, second information. Find the constants p and q. So all we have to do is just plug in. So 9 when n is 6, I'm using the same formula. 9 is equals to p into 6 plus q, first equation. 9 equals 6p plus q. And now the second equation using the same, it is 11 when n is 9. So 11 is equals to 9p plus q. Equation 1 and equation 2, we can just subtract these two. So 9 is equals to 6p plus q, and I'm subtracting the second equation, 9p plus q. When we do so, these signs are going to change. Minus 2 is equals to minus 3p, and we get rid of this. So minus minus goes away, and p is equals to 2 by 3. Now use any of the equation again. 9 is equals to 6p plus q. 9 is equals to 6 into 2 by 3 plus q. 3 1 times, 3 2 times, 2 2 times is 4, and q is equals to 5. Any confusion? So we'll skip the questions which are similar. Question number 6 says find the first negative term. Okay, this is a little different. Let's try this. So question 6 says find for an arithmetic sequence u3 equals 30. u3 is equals to 30 and u9 is equals to 9, and we can already see that it is decreasing from 30 to 9. Moving forward, it is decreasing. Find the first negative term in the sequence. So I'm going to write the general terms. un is equals to a plus n minus 1 into d. There are two ways to solve this. One way is this, the other is that we know that from 3 to 9 there are 6 terms, and 9 minus 30 divided by 6 will give us the difference. So 9 minus 30 is 21, divided by 6 is minus 3.5. So the difference is negative 3.5. So I can also find the first term using this manually, but let's go through the formula. So when I'm using 3, it is 30. 30 is equals to a plus n minus 1. Sorry, that is 3 minus 1 and d. So 30 is equals to a plus 2d. On the other hand, the second equation, u9 is equals to 9. So 9 is equals to a plus 9 minus 1 into d. 9 is equals to a plus 8d. I'm using these two equations to solve them and find a and d. If I make it like this, 30 is equals to a plus 2d, first one, and I'm subtracting the second one. So plus 2 minus, plus 2 minus, plus 2 minus. So 30 minus 9 is 21. We get rid of this a, and that is minus 6d. So d is equals to 21 by minus 6. 21 divided by 6 is 3.5 with a negative sign. So whatever method we choose, we get the same answer. Now for a, 30 is equals to a plus 2d. So 30 minus 2d is equals to a. 30 minus 2 into minus 3.5 is equals to a. 30 plus 7 equals a, and a is equals to 37. Now I can write the formula. A plus n minus 1 into d un, and I'm going to fill in the values where a is 37. This is the general term, and common difference is minus 3.5. Just simplifying before we move further. Minus 3.5 n plus 3.5. So 37 plus 3.5 is 40.5 minus 3.5n. So this is my formula, and the question says find, what was the statement? Find the first negative term of the sequence. So to find the first negative term, 40.5 minus 3.5n should be less than 0. So when it is that, we have 40.5 is less than 3.5n, and I'm dividing it. 40.5 divided by 3.5 should be less than n. 40.5 divided by 3.5, and I'm getting 11.57. So n should be equal to 12 when we get the first negative term. Let's check that quickly. So 40.5 minus 3.5 into 12. So I'm getting negative 1.5. And just to make a quick check, with 11 I'm getting positive 2. So first negative term is minus 1.5. Let's try these exam style questions. Question number 9 says the first three terms in an arithmetic sequence are as shown. Find the two possible values of k. So if it is an arithmetic sequence, that means we have common difference minus 8, k squared and 17k. Now I'm looking at these two conditions. First, these two difference would be equal to k square minus 8. Second value minus the first value. So this is D. And then I'm looking at the second two. Difference could also be 17 k minus k square. Second value minus first value. Now I'm going to equate these two differences. So k square plus 8 is equals to 17k minus k square. We rearrange, this becomes 2k square minus 17k plus 8 is equals to 0. So to get two different values, 2k square minus 16k minus k plus 8 is equals to 0. And taking out common, k minus 8 minus 1, k minus 8 is equals to 0. That would be 2k minus 1. K minus 8 is equals to 0. So one is k is equals to 8. And the other is k is equals to 1 by 2. These are the two possible values. Question number 10. An arithmetic sequence was first term k square and common difference. Arithmetic sequence, the first term k square and the common difference is k. This is A and this is D. Where k is greater than 0 positive, the fifth term of the sequence is 41. Find the value of k, giving your answer in this form. Okay, so let's extract the information. First term k square, common difference is k, and t5 is 41. So tn is equals to a plus n minus 1 into d. We know this is 41 when n is 5. A is already given, which is k squared. When n is 5, we have the value of d, that is k. 41 is equals to k square plus 4k, rearrange k square plus 4k minus 41 is equals to 0. And this thing has made it pretty clear that we'll have to go through quadratic formula. So minus b plus minus square root b square minus 4a is 1 and c is negative 41 over 2a. Using the calculator, minus 4 plus square root 4 square minus 4 into minus 41 by 2, and I'm getting negative 2 plus 3 square root 5, and the second one is negative 2 negative 3 square root 5, and the condition was that k is greater than 0, so this is rejected and this is our answer. Any confusion? Okay, next topic is the sum of terms. For example, we have 2, 4, 6, 8, 10. This is the sequence, and if we add up to whatever value of n you want to, you can find. So sum is represented by Sn, and we have these two different formulas. First is this: Sn is equals to n by 2 into a plus l, where a is the first term, n is the term number, l is the last term. If we talk about this sequence, 2 will be my first term and 10 will be my last term. And if I just find that term, like this is a, and any term could be found, I am replacing this last term with this u, n is equals to a plus n minus 1 into d. We can always get the last term when we plug in the value of n, which is actually the last one in this case, which is 5. So if we just replace this n minus 1 into d, simplifying n by 2, we open up these brackets, this becomes 2a plus n minus 1 into d. So this is how you get this second formula. So if we just check it quickly, I'm adding all these manually. 2 plus 4 plus 6 plus 8 plus 10 is giving me 30. And if we plug this in the given formula, these are 5 terms. So S5 is 5 by 2 into 2. First term is 2 plus 5 minus 1 is 4. Common difference is again 2. And 2.5 into 2 into 2 is 4. 8 plus 4 is 12 into 2.5 is 30. So we get the same sum. Now if someone would say that use the same sequence and find the sum of first 117 terms. So if we go for manual addition, we'll definitely make a mistake and it would take very, very long. So we use these given formulas. Examples, and exercise. So find the sum of the following series: 3, 7, 11, 14. We are just adding these, and it is given that we have 20 terms. So Sn is equals to n by 2, 2a plus n minus 1 times d. So we are finding sum of first 20 terms. 20 by 2, I can see the first term is 3. 2 into 3 plus 20 minus 1 times d. Difference is 4. And the use of machine: 2 into 3 plus 19 into 4 times 20 divided by 2, and the sum is 820. All of these are almost the same. Let's try this H part. H part says, let me change this color. It is already given and I have to find the sum of following series. Okay, if you just have a look at this, this is 1, then 2, then 3, and so on. So these are first 21 terms. Studying the sequence, we get that these are first 21 terms. So sum of 21 terms is equals to 21 by 2 into 2a. First term is x plus 1. So 2 into x plus 1 plus n minus 1, that will be 21 minus 1, and the difference. If we just subtract these two, we get rid of 1 and the difference is x. Just a cross check, if we subtract these two, we get rid of 1 and difference is still x. So 21 by 2, that is 2x plus 2 plus 20 into x, that would be 22x plus 2, and on the outside that is 21 by 2. We divide with 21 by 2, that is x plus 1, and multiply 11 into 21 is 231. X plus 21 is the sum. Question number 2 says, find how many terms of the sequence are needed to make the given sum. Okay. If we talk about this, We know all the things, only n is missing. So when sum is given, I'm using this formula, n by 2 into 2a plus n minus 1 into d. So sum is 670, n is unknown, where first term is 5 plus n minus 1 and the difference is 3. We just have to simplify this, having known that we have only one unknown. 670 into 2 is giving me 1340. I'm keeping n on the other side, that is 10 plus 3n minus 3. 1340 is equals to, this is 7. 7 into n is 7n plus 3n square. Rearrange 3n square plus 7n minus 1340 is equals to 0. And now we can use quadratic formula, minus b plus minus square root b square minus 4, b is 7, b square minus 4a and minus 1340 over 2a, minus 7 plus square root b square minus 4 into a into c over 2 into 3. So I'm getting the first value, which is 20 with a positive sign, and when we plug in the negative sign, I'm getting negative 67 by 3, which is rejected because the terms cannot be negative. So we need the first 20 terms to get a sum of 670. Can you speak a little louder? Okay, the second formula. For example, we have this. Second formula is n over 2 a plus l. For example, I know the last term 2, 4, 6, 8, and it keeps on continuing till 100. So when I know the last term, I can use this formula to find. Or let's say we don't know that and we can first find it. This is actually the same thing, because we can find the last term if they say that find up to the 100 terms. So I know that this is table of 2, 2, 4, 6, 8. Last would obviously be 200. In that case, I can say 100 by 2 into first term plus last term, and we'll simplify. In other words, we can always find the last term, a plus n minus 1 into d. A was 2, n is, in this case, if we say we have 100 terms, so that is 100 minus 1, and the difference is still 2. 2 plus 99 into 2, and I'm getting 200. So 200 is the last term. We just plug in these two values and solve for it. 50 into 202. The sum is 10100. Clear? So find the sum of first 50 even numbers. Even numbers would be 2, 4, 6, 8. First 50, I know what A is, I know what N is, I know what D is. So we just plug in these values in the formula. Number 4 says find the least number of terms for this to exceed 1000. So sum should exceed 1000. This is n by 2 into 2a plus n minus 1 into d. Now I will be plugging in the values on right hand side. So it should exceed 1000. This is 1000. N is unknown. We can see that the first term is 7. So 7 2 times is 14. N is again unknown. And the difference between these two is 5. So we can simplify this inequality to get the value of n, where the sum would increase 1000. So I'm bringing 2 on the other side makes it 2000 is less than 14n, and that is 5 into n is 5n squared minus 5 into n is minus 5n. Keeping on simplifying, 5n square, 14 minus 5 is 9, minus 2000 is less than 0. And I'll choose quadratic formula, minus b plus minus square root b square minus 4a negative 2000 c over 2 into a. So minus 9 plus square root 9 square minus 4 into 5 into minus 2000 over 2 into 5 is 19.1, and with the negative sign is negative 20.9. So I'm straight away rejecting this and cannot be negative. Now we had an inequality, so when n is, we took all of them on the right side, so when n is greater than 19.1, n should be equal to 20. So when n is 20, the sum would exceed 1000. 5 says the first term of arithmetic series is 4, a is equals to 4. The sum to 20 terms is minus 15, Sn is equals to minus 15. Find in any order the common difference and 20th term. So d is equals to unknown and t20 is equals to unknown. So what information is given? That is sum. So Sn is equals to n by 2 into 2a plus n minus 1 into d. Sum is negative 15 and these were 20 terms. So this was 20. So 20 by 2 is equals to 2. A is 4. 20 minus 1 into d. And we keep on simplifying. This is 10. So negative 1.5 on left hand side. And this is 2 4 times 8 plus 19d. Negative 1.5 minus 8 is equals to 19d. So 8 and 1.5 is 9.5 by 19 is equals to d. This is negative, divided by 19 we get negative 1 by 2. Even then we'll get the same answer if you multiply it inside. For example, minus 15 is equals to, this was 10. If you keep 10 right here, you will be multiplying it to get 80 plus 1 90d. In that case it would be this. So let's check that. Negative 15 minus 80 divided by 190, you still get negative half. Yeah. So D is done, and term number 20. So T20 would be equal to A plus n minus 1 into D. First term is already there, which is 4 plus 20 minus 1, and D is negative 1 by 2. That is 4 into 19 divided by 2. 4 plus negative 9.5 is negative 5.5.